Hi everyone, in this tutorial we're going to talk about STM32 touch sense controller, which is a great peripheral on STM32s to detect proximity or touch on electrodes. Without further ado, let's get into it. Alright, so let's see how STM32 touch sensing controller works. I got this diagram from one of the ST presentation, which I will include the link in the description. And let's talk through it now. So here we're talking about 7 steps, and let's start with step 1. So in step 1, we basically uh, close S1 and S3. So in this case, we are making a circuit from CX to the ground here, and also from CS to the ground here. In this step, we basically discharge both capacitors. So CX in this case is the touchpad or yeah, the touch sense. And then in the next step, we open everything S1, S2, and S3, and basically we are creating a dead time. I'm not quite sure at this stage what's the usage of dead time, but probably for stabilizing the system. And then in the next step, we close S2 here. So when we close S2, we are transferring charges to this Cx here, which acts as a capacitor at this stage. But for now, there is only one side of this capacitor, right? Then in the next step, we open everything again. We make a dead time here, step 4. And in step 5, we close S1 and we create a circuit from Cx here to Cs here. We're basically transferring all the charges to CS here, and this will result in increasing the voltage of CS. The next step is again dead time, and we go back again to step 3. So again we close S2, we transfer charge here, we close S1, we transfer those charges back to CS, and it will increase the voltage of CS a little bit. And we do this over and over until the the voltage or the logical level on CS reaches 1. Let's say for the simplification, let's say 2 volts, okay? And then we see how many times we did this cycle. So we did it, let's say, for 100 times. We did 100 times of S2 charging CX, transferring the CX charge to the CS, and then do it over and over for 100 times. And now let's compare it with the state that finger is close to the CX. As the finger is closer to the CX now, and we have the body basically, which is kind of coupled with the earth or ground. What happened here is that when we close S2, more charges will be accumulated, will be transferred and accumulated on CX. So let's do it step by step. We close S2, we transfer charges to CX. As it is close to the finger, more charges will flow here. And then we close S1, we open S2, and those charges will be transferred to CS, sorry. And basically here, as there were more charges on CX, there will be more charges on CS every time we do this sequence, and that means the voltage on CS will increase more this time. And as a result, we need to do less amount of less cycles to charge CS. For example, in this case, as we have the finger close to the touchpad here, it will require, let's say, 80 times. And now if we compare 80 times with 100 times, we know that something is closer. If we take the finger away, that will actually increase. So 80 now will be 90. And if we take it away, it will be 100 again. So with this technique, we are kind of estimating how close the finger or how close the other material here, it can be body or it can be anything else, how close is it to the um, touchpad here. So that's how actually the touch sensing works in STM32s. Now let's look at how it's actually implemented on STM32s. So we have the plates here. We have a group. So each group in STM32 consists of 4 pins. These are the pins that are actually designated for touch sensing controller, and unfortunately you cannot change these like other pins. You cannot remap them to other pins. So there are certain pins that you can use for this case. In each group you can connect 3 pads like this, and then you have to assign one of the pads to be the sampling capacitor, and for that pad, that pin, you have to connect it to a capacitor. For example, I connect it usually to a 100 nanofarad capacitor. Here you can see my setup for this project. I'm using a Nucleo F072RB board, and this microcontroller has the TSC controller, and I use these 2 pins here. So I basically connected a capacitor between these 2 pins. So this one is GND and this one is PB2, and as you can see here, here's the capacitor that I used. And then basically I have a plate here. It's a mesh grid, and I connected to this pin, um, which is I think PC6 if I'm not wrong. And that's my setup. And now let's go to the next step and prepare the project. Writing the code for the TouchSense controller is fairly simple, and let's start with creating a new STM32 project. For the board, I select Nucleo F072RB. Next, and for the project name, I'll give it TSC. That's it. And in here, we start with opening system core here, going to TSC. That specific pin, PC6 that I was talking about, I think it's on, let me see again. So PB2 is group 3. So first we assign PB2. PB2 is, where is PB2? PB2, yeah, here it is. We assign it G3IO4. Okay, so from here I activate G3IO4, and actually I don't activate that one because I am using that one as a sampling. So I put it here, sampling G3IO4, and then I'm using PC6 as one of the touch input. Oh, okay, so apparently I'm wrong there. And let's see, that is PC5, I think. Yeah, PC5. PC5. Okay, let's search for PC5. Here it is, and that's G3IO4 IO1. So I activate G3 IO1, and that's it for this part. I don't change anything here because I don't want to go into too details. I just want to have a very basic setup running, and then you can basically play with these options later yourself. Let's go to the middlewares. Here we want to activate the touch sensing library. I enable it. Here I just need to say how many touch keys I have. So I have one touch key, and this is basically stands for touch key basic. So I have one touch key, and it automatically populates the G3IO1. And yeah, I think that's it. And then I think just check if the clocks are fine. Yeah, everything is fine, so I just generate the project. Next, I'll open the project here. Just jump into the main.c file, and here what you need to do is basically writing TSL. It's the library in it. So we initialize the library, and here you just write TSL user execute. So what this function does is basically I don't know if there is any document for this, but it basically does the calculation, and then let's run the project in debug mode. And let's add this variable, my t key is b, into live watch, live expression, and from here let's just have a look on the state of the touch key. So here you can see it automatically did the calibration, and it's already in the release state now. It changed from release to proxy and then detect, and you can change the um, sensitivity in your code. For this case, I just bring my hand close, and I see the value here. So if I bring my hand close, I want it to be in proximity mode around here. So I want to be in proximity mode around here. So that's gonna be 350, almost 350, and anything above 1,000 would be detected, or we can say 2,000. So we can hard code that in your code. In order to do that, we just jump into the mighty keys b dot it's in parameters. Actually, we should go for the first one, and then here we go for parameter. So for us, the proximity in is, let's say, 350, and just add another out here, and we say like anything be after it got into in, anything under 320 means it's out of proximity. And then also you want to say my t keys 0 again, that param, and this would be detecting, and for the detect we say 2500, and detect out would be let's say, I don't know, 2000. These are basically, you have to get to this by just some try and errors. Let's try again. Run it. Let's open everything again. So let's try it again. So now, yeah, now in the proximity, And now in detect proximity, detect. But for my case here, it doesn't work very good. Let's see what's the problem is. Okay. Oh, okay. Why these are not updated? Interesting. Mm, my touch keys B 0 P underline param. Okay. What's that? Oh, it should be int 8. That's interesting. Hmm. Detect in. This is also int 8. However, delta goes up to int 16. Okay, so after reading a bit about the problem that we have, I realized that we have a problem where the sampling capacitor is super big compared to the size of the electrode that we are using. So basically here you can see it takes 6,000 almost 6,000 cycles to charge that capacitor. So we have three options here. We can either um, decrease the capacitance, the sampling capacitor, to something like 20 picofarad or 25 picofarad or something in this range, or we can increase the size of the electrode itself, which basically causes more charges to accumulate on it, and it results in charging the capacitor faster. Or there is another option which we can use, and I realized that there is a TSL config file here, and in this file and you have a TSL parameter coefficient, which basically you can multiply the threshold by a fixed value. So here, for example, if you use 4, like it will multiply the thresholds by 16. So let's put 4 here, and let's go back to main. Let's change the parameter that we had. So let's enter 350 divided by 16, so it would be almost 22 for proximity in, and then let's put 2500 by 16 would be 156, and then this one relative to that one 20, and this one maybe 150. Let's say 3. Now let's try it. Okay, let's run the code and let's have a look here. So now it's in its release state, and let's try to bring our hand close. Okay, so it's in proximity, and yeah, as I'm getting closer, it said touch. So again, I'm doing it once more. Here it is. So now it's in release, proximity, and detect. So that's a very basic setup for touch sensor. or touch sense controller. Okay, now let's add one more thing to this, and let's turn on the LED when we are in proximity of the sensor. In order to do that, one thing you can do here is basically you can check if the status of this function, the execution function, is okay. mm, by checking that it's not busy basically. If what was it, TSL, let's see, what was it, status busy. If it wasn't status busy, then we basically put an if here, and let's have a look at here. So it is my T keys B and then 0, and then here we are looking at, I think, CHD, right? And then, oh sorry, you're looking at param, and then, oh no, you're looking at data. State, if the state is, let's see what the states it can have. If the state is detect, then basically we turn on the LED. Right pin, I think it's LD to GPIO port and LD to pin, and then I think it's turned on by GPIO pin set, and then else basically is just opposite of this, and it is reset. Now let's run this. Yeah. Alright, it's running, and let's try it. Yeah. When I touch it, it turns on the LED. And I think that's it. And yeah, thank you so much for watching, and see you in the next one.